welcome to Fascinating Frontiers, episode 138. It's July 21st, 2026. Here's what's happening in space and science today. Astronomers have watched a distant galaxy's central black hole erupt for the first time in real time after two prior outbursts went unseen until they faded. The black hole at the center of galaxy IC 3599, roughly 280 million light-years away, flared for the third time in 35 years. Previous outbursts in 1990 and 2010 were reconstructed only after they ended. This event marks the first time researchers observed such an outburst unfold while it was happening. A multi-wavelength analysis paper was posted to the arXiv preprint server on July 10th. Follow-up observations across wavelengths are expected to clarify the trigger mechanism. Real-time multi-wavelength coverage now offers the first direct view of how the outburst evolves across X-ray, optical, and radio bands. The 280 million light-year distance means the flare we see today began long before humans existed, yet the timing allows comparison with the two prior episodes spaced roughly 2 decades apart. If the sun were scaled to the size of a basketball sitting in downtown Toronto, the supermassive black hole in IC 3599 would still be smaller than a marble, yet contain millions of solar masses crammed into a region only a few times wider than that marble. When fresh gas spirals inward, friction heats it to millions of degrees and launches a sudden surge of radiation and outflowing material that can outshine the entire host galaxy for weeks or months. In the case of IC 3599, the cycle has repeated at least 3 times in 35 years, each time expelling enough material to temporarily starve the black hole of fuel. One surprising number stands out. The 280 million light-year distance means the light we receive now left the galaxy when the first dinosaurs were evolving on Earth. Yet the flare's rise and fall were captured in hours rather than pieced together years later. The open question is why the same galaxy produces these dramatic resets on decade-long timescales, while most other active nuclei remain relatively steady for centuries. From the sudden clearing of material around a distant black hole to the deliberate building of permanent infrastructure that will keep humans connected on the moon, the European Space Agency program will deliver continuous communications and navigation services between Earth and the moon. It targets high-speed data links and precise positioning, especially at the lunar South Pole. Moonlight is being developed with international agencies and industry partners to support an interoperable lunar ecosystem. The infrastructure is intended to underpin sustained human operations rather than one-off landings. This development advances the Artemis and the Moon program by adding the communications backbone needed for extended surface stays and repeated landings. Next steps include further partnership agreements and initial service demonstrations. With the communications layer now planned, attention turns to the actual habitats where crews will live and work. NASA is advancing plans for humanity's first surface outpost where crews will live, work, and explore. The outpost forms part of the broader return to the moon architecture that also extends toward Mars. Details are available through dedicated NASA resources tracking hardware and operations development. This effort builds directly on prior lunar mission experience and current commercial partnerships. The announcement moves the Artemis and the Moon timeline forward by shifting focus from landing hardware to the permanent facilities astronauts will need once they return. Observers should watch for updates on habitat systems and power infrastructure. Neil Armstrong and Buzz Aldrin walked on the moon on July 20th, 1969. The anniversary highlights the milestone that began crewed lunar exploration. NASA continues to reference that achievement while preparing new surface operations. The event remains a reference point for current Artemis planning. This historical marker reinforces the long-term continuity of the Artemis and the Moon effort, reminding teams that the original landing set the baseline for what sustained presence must achieve. Saturn's largest moon, Titan, shines at mid-8th magnitude and is larger than Mercury. Observers with telescopes can spot it near the ringed planet this morning once the planet rises. Titan offers a steady target for modest instruments throughout the week. The column provides timing details for other visible events. While agencies plan tomorrow's surface infrastructure, today's observers can still enjoy a simple celestial reminder of our long lunar connection. Researchers produced the first detailed reconstruction of magnetic fields across an entire galaxy cluster. The map links the mechanism that powers gigantic radio emissions to the cluster formation process. The work provides a new view of how these vast structures organize magnetic energy on the largest scales. Future observations with upgraded radio arrays should test the model against additional clusters. From the vast magnetic architecture of galaxy clusters, we zoom in to a single star system where two telescopes recently uncovered a hidden world. Astronomers combined data from two telescopes to detect a planet previously missed because of glare from its host star. The discovery demonstrates how coordinated observations can reveal worlds that single instruments overlook. The planet's characteristics are now under further study to determine its mass and orbit. Additional follow-up is planned to refine the detection. 4 new white dwarfs were identified within about 65 light-years. Each is paired with a brighter red dwarf whose light previously masked the white dwarf. The systems were once common envelope binaries. Improved imaging and spectroscopic techniques allowed the fainter companions to be separated. An international team traced the Cretaceous Paleogene impactor to a rare class of rock originating in the outer solar system. The analysis combines geochemical signatures with dynamical models of asteroid and comet populations. This narrows the possible source regions compared with earlier, broader hypotheses. Further meteorite samples and modeling will test the conclusion. The most detailed portrait yet of the 4 planets orbiting Barnard's star shows conditions hostile to known life. The study combines radial velocity data with atmospheric and interior models. All 4 worlds appear to lack stable surface environments or protective magnetic fields. Continued monitoring will refine the mass and orbit constraints. A University of Texas at Austin-led study proposes that little red dots represent an early stage in globular cluster formation. The model suggests the compact red objects observed in the early universe evolve into the dense star clusters seen today. The findings appear in the Astrophysical Journal Letters. Spectroscopic follow-up with current facilities could test the evolutionary link. The article explores concepts for turning orbital debris into usable material rather than treating it solely as hazard. Approaches include capture, processing, and repurposing techniques under development by various teams. The shift in perspective could affect future mission design and debris mitigation policy. Technical demonstrations are needed to move concepts toward operational use. Differences in bedrock type and river sediment distribution create contrasting coastline shapes west and northeast of Portland. Satellite imagery reveals how these geological factors control erosion patterns. The observations help refine coastal change models used for planning. Continued monitoring will track how storms alter the current configuration. Giant sequoias in forests managed with prescribed burns were nearly 4 times more likely to survive extreme wildfires. The study quantifies reduced tree mortality linked to lower fuel loads. Results come from field data collected across multiple burn histories. Land managers are incorporating the findings into updated fire management plans. Japan's IHI is evaluating Finnish startup Kuva Space hyperspectral satellites for a planned 100-satellite Earth observation constellation. The sensors would add detailed surface composition data to the multi-sensor system. Integration studies are underway to assess compatibility with existing Japanese platforms. A decision on inclusion is expected after technical reviews. Next time, keep an eye on further multi-wavelength data releases from the IC3599 monitoring campaign. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. And before you go, This show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com/gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through